Hi, and welcome to this session all about the factor theorem and dividing polynomials. So this is one of those things that often gets skipped or missed out or used in other topics as for A-level maths, but it's really important and really, really useful. So let's go through what we need to know for the factor theorem and dividing polynomials, and we're going to work through an exam question together so you can see the kind of thing that you can be asked. There is also an accompanying worksheet for this session which is jam-packed full of past exam questions, so you can see the kinds of things that are asked and have practice yourself. So we're going to cover the factor theorem, the remainder theorem, which some of you might not have heard of, but is worth knowing and is kind of useful, and dividing polynomials. So the factor theorem states that if x minus a is a factor of f of x, then f of a is equal to 0. So an example of this might be that I have, let's get a colour that will write on this whiteboard. If I am told to show, using the factor theorem, that x minus 2 is a factor of x cubed plus x squared minus 4x minus 4. To prove that, I substitute in x equals 2. And if I get 0 as my answer, then I have shown that this is a factor of this equation. So I can say 2 cubed is 8 plus 2 squared is 4 minus 4 times 2 is minus 8 minus 4. And that is indeed equal to 0. Now that is worth 2 marks usually in an exam. But you have to show the working. You can't just go x minus 2 equals 0. You have to show some working, and you have to say that because it's equal 0, therefore x minus 2 is a factor. You have to be really clear and explicit about it, and that's where the practice and being able to mark your work against the solutions is really, really important. So that's the factor theorem. Now, the next thing we're going to look at is the remainder theorem, which you might not have heard of, but is the factor theorem is actually a very specific example of the remainder theorem. The remainder theorem states that the remainder when dividing f of x by x minus a is equal to f of a, which is a generalization of the factor theorem, because the factor theorem states when dividing f of x by x minus a, you would get 0 as your remainder, which is equal to f of a. So an exam question I might be asked around this is to give the remainder when f of, I'm not writing, bear with me 1 second. If I have f of x is equal to 6x cubed plus 3x squared plus 2x minus 1, and I'm asked to find the remainder when this is divided by x plus 1. Well, I could do the division. That's going to be really long-winded. The remainder theorem gives me a shortcut. If I do f of minus 1, that would give me minus 6 plus 3 minus 2 minus 1, and that would give me minus 6 plus 3 is minus 3, minus 2 minus 1 is minus 6. And that would be my remainder when I divided f of x by x plus 1, which is much nicer than having to do the division. And again, there are some practice questions of this form in the worksheet. Now, here's for the big guns, the dividing polynomials. A question we might be given is something along the lines of factorize completely 2x cubed plus 3x squared minus 18x plus 8. Whew. Now, I'm going to run through how we divide polynomials by working through this question, because it's much easier to explain as we go along rather than trying to explain it up front. So the first thing I need to do is find a factor of this polynomial. And an obvious place to start is x is equal to 1. It's just a nice one. We know it's not going to be 0 because if I substitute in 0, that's not going to be equal to 0. So let's try x is equal to 1. If I substitute in x is equal to 1, I get 2 plus 3 minus 18 plus 8, and that is equal to minus 5, which is not equal to 0. So that's not a factor. So let's try x is equal to 2. 2 times 8 gives me 16, plus 3 times 4 gives me 12, minus 36, plus 8. Well, that gives me 0. And so I can say with certainty that x minus 2 is a factor of this polynomial. So we found our factor. Now for the long division. Oh, it's really hard to do this on a whiteboard. It's one of those things where you need lots of space. Plus 8 and x minus 2. Oh dear, that x came out a bit skewy. So we go, what would I times xy to get 2x cubed? Hopefully that's fairly obvious that it should be 2x squared. I then times the 2x squared by everything in my factor. So 2x squared times x gives me 2x cubed. And 2x squared times minus 2 gives me minus 4x squared. Subtract those. I get 7x squared minus, carry down the 18x. Again, same thing. What would I times x by to get 7x squared? 7x. Times that by x minus 2, I get 7x squared minus 14x. Take those away. That bit cancels. Minus 18 minus 14, same as plus 14. I get minus 4x. I'm going to run out of space. Plus 8. Oh dear. X times what gives me minus 4x minus 4. And then that would give me minus 4x plus 8. And then when I take those away, it gives me 0. That's our dividing. So we've now got that our 2x cubed plus 3x squared minus 18x plus 8 becomes x minus 2, 2x squared plus 7x minus 4. And so now I have a quadratic to factorize, which is much nicer because that's going to become x minus 2 stays the same. That's going to become 2x and x. 4 is a nice number at the end because there's only two ways to make 4, 4 and 1 and 2 and 2. If I double the 4 and I minus 1, that will give me the 7. And so that is my polynomial fully factorized. And there you have it. That is the factor theorem, the remainder theorem, and how we divide polynomials. If you have any questions about that, drop me a message in the comments. Always happy to help. But otherwise, I fully encourage you to go off and have a practice. You'll see the kind of marks that these questions are worth. They're quite big, actually, for the amount of effort they are. So go and have a practice. There are fully worked solutions as well. And yeah, pop a comment in the box below if you have any questions. Thank you guys for watching, and I look forward to seeing you next time. Bye.